This is section 4.11 in module 4, page 60. So it's all about the tide line and just doing some math with tides, which is a periodic event. Perhaps you've built an elaborate sandcastle on the beach only to have it get swept away by the incoming tide. Frustrated by having your sandcastle knocked down by the tide, you decide to pay attention to the tides so that you can keep track of how much time you have to build and admire your sandcastle. You have a friend who's in calculus, will be going to the beach with you. You give your friend some data from the almanac about high tides along the ocean, as well as a contour map of the beach you intend to visit, and you're asking to come up with an equation for the water level on the beach on the day of your trip. According to your friend's analysis, the water level on the beach will fit this equation. So the function is f of t equals 20 sine of pi over 6t. In the equation, f of t represents how far the tide is in or out from the average tide line. This distance is measured in feet, and t represents the elapsed time in hours since midnight. So when the tide comes in, it's closer, and the tide goes out is further, and there is this average tide line. So question 1 is asking, what is the highest up the beach compared to its average position that the tide would be during the day? This is called high tide. And what is the lowest that the tide will be during the day? This is called low tide. So keep in mind that because of this function, you have an amplitude of 20. So we'll talk about the graph more directly in a minute. But the highest this graph would go would be 20 and negative 20, because this equation has no vertical shift. So whatever your tide is going to look like, it's going to be an equation something like this. So the high tide is going to be 20 feet. And the low tide is going to be negative 20 feet. So just realize that if this models the tide, because the amplitude is 20, high tide is 20 feet, low tide is negative 20 feet. The next question says, suppose you plan to build your castle right on the average tide line, just as the water has moved below that line. How much time will you have to build your castle before the incoming tide destroys your work? So if you think about this sketch of the tide, and this is as time passes, and time 0 was midnight, the question is when will the water be receding? So this is all going to be high tide, this is going to be low tide, and if your castle is going to be built on the average tide line, just as the water moves below that line, you want to know from here to here how much time is this, because that's how much time you would have. So the question is, if you knew the period of this function, you could take half of it, because that's half of one curve of that graph. So as we've seen before, the period is 2 pi divided by the coefficient in front of the variable, so that is pi over 6. So 2 pi divided by pi over 6 is equivalent to multiplying by 6 over pi, and that would simplify the following. So this would be 12. So the period of this graph is going to be 12 hours. Okay, so that's how long it's going to take to show one period of this graph. So that means if it's 12 hours, this would be 12 hours, this would be 6 hours. And the question is, how much time would we have? Well, we would have from 6, actually be 6 in the morning till noon to build that sandcastle. So the answer to the question would be, we have 6 hours to build the castle. So the time would be from 6 in the morning, not to build the hours, to build the castle. So the time would be from 6 in the morning till noon. But the answer to the question is, how much time will you have to build the castle? You'd have 6 hours. Okay. The next page talks about, for question 3, can you go through and use the graph in your answers to graph 2 complete tide cycles and then label and scalable as axes. So keep in mind, we're going to graph this function, f of t equals 20 times the sine of pi over 6t. they want us to show 2 complete tides. So if it takes 12 hours for 1, then we want to go through and show 2, so we want to go to 24 hours. So we have to scale this, and our amplitude has to be 20. So we have how many squares? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So if I count every square as 2, that'll get me to 20. So I'm going to count this much as 4. I don't want to label I'll label every other one. So that's going to be 8, 10, 12, 14, 16, 18, 20. And then going down below. So this would be -4, and then count 2 squares, -8. 2 more squares, -12, -16, -20. And I want to go through and go to 24 to show 2 cycles of this high and low tide. So I've got to go to 24. I don't think I have 24 squares though. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Maybe 1, 2, 3, 4, 5, 6, 7, 8. I do. So I'm going to label every other square by 2's. So counting every square is 1. And then I'll sketch this graph. So the graph just needs to show 2 cycles. So there's 24. So at the beginning of the graph, because there's no vertical shift on that equation, I'm going to start at 0. So midnight the tide is at 0, which is the average tide line. After 12 hours, it's also there, and 6 would be also there. So those are 3 of the points. In between, there's going to be a high tide. So the high tide is going to be between 0 and 6, which would be 3. And that was at 20, their amplitude. And then between 6 and 12, there is a middle value called 9, and that's going to be at -20. So this would be 1 cycle of that tide. So it would look like this. So there's 1 cycle. And if I graph that again, I'm going to go to 24. Halfway between 12 and 24 is 18. Between 12 and 18 is 15, so that's going to be another high tide point. Between 18 and 24, that's a gap of 6, so take half of that. 3 is going to be 21, so that's here. So this is just another graph that is showing high and low tides. And our beaches have, on average, 2 high and 2 low tides every day. It changes based on the pull of the moon and Earth and the location and position, but there's pretty much 2 highs and 2 low tides every day. Sometimes they are a little more extreme than others. So that's what question 3 asks. Question 4 went ahead to say, suppose you want to build your castle 10 feet below the average tide line. So 10 feet below is going to be here. So this is 10 feet below, because that would be a -10. So that means it's going to be along this line somewhere. The question is, what is the maximum amount of time you'll have to make your castle, and how can you convince your friend that your answer is correct? So they want you to use the graph to estimate it, and then use inverse sine function to find the exact value. So an estimate would be something like, alright, I'm right here, and I'm right here. So what would those times be? So here would be an estimate. Let's see, it seems to be, I'm going to guess from 7. That seems to be maybe 7, and this might be, I don't know, 10, 11, a little, maybe 11 and a half. So I'm going to estimate that it's going to be from 7 to 11.5. And that's just using my graph, so that means the tide would go out. So I'd have dry sand, the water eventually comes back. So this would be my time frame, from roughly 7 to 11 and a half. So what's the maximum amount of time? I would say from my estimate we would have, so we have what, that's from 7 to 11 is 4, so we have 4.5 hours to build that sandcastle. I really want to go through and solve this equation though, and that's going to be more accurate. So my equation is, when is our tide going to be at -10? So we had -10 equals 20 times the sine of pi over 6t. And they want us to go through and solve that. Let's go through and solve that. And decide what happens. So if you want, go ahead and pause the video, solve that equation, and then we'll come back and decide what you get and how we work with that answer and what the calculator seems to be giving us that may not be very helpful. So to begin solving that, if I divide both sides of the equation by 20, I'm going to make it as a decimal. That'll be negative 10/20, negative a half. I'm going to write it as negative 0.5 equals the sine of pi over 6t. And because this is our angle, the pi over 6t, that's in radians. There's no degree measurement, so just be aware that your calculator should be in radian mode. And now I want to take the inverse sine. So I'm going to do the inverse sine of negative 0.5 equals pi over 6t. So that's the math that takes away the sign in front of pi over 6t. So on a calculator, I have to do inverse sine of negative 0.5. So on my calculator, which is this, there it is. So on my calculator, I do inverse sine. So I first have to type in negative 0.5, and then I type in second sine, and that's how this calculator works. It gives me negative 30. So I get negative 30 equals pi over 6 times t, which means t is going to equal negative 30 times 6 divided by pi. So here is my time that according to calculator. So I'll take that negative 30 and I'll multiply by 6 and get that, and if I divide that by pi, and my calculator has a pi button, I get negative 57. But you know what, I'm not in radian mode, so scratch that. So let's go back and redo everything. So it's 0.5, make it negative, and then I have to be in radian mode. I know it's radian mode because it says rad in the corner now. I had to touch that bottom button. So I take negative 0.5, and now I'm in radian mode, and I do inverse sine. And instead of this being negative 30, this ends up being, because negative 30 would be negative 30 degrees, this would be negative 0. And I'm going to go to 2 decimal places, 5.2. So I get negative 0.52. So I'm going to take this, so this is really not going to be this value. This is going to be 0.52. So I'll take that, and I'll multiply by 6, and then I'll divide that by pi. And I'm getting negative 1. So I'm getting negative 1, not really approximately, it's pretty exact. So that's my time. So that's the calculator. The calculator gave me negative 1. So that's the time. Now here's what's going on with the calculator. The calculator says the time is negative 1, which isn't helpful because according to my graph, there is no time that's negative 1. So notice there's something happening with inverse sine that's giving me a numerical answer that is accurate in terms of mathematics, but it doesn't fit the situation because there is no time that is negative 1 when I'm going to this beach. There is no negative time on my axis, but I could go backwards, and if I'm counting by 2's, this would be negative 2, so this would be negative 1 right there. And if I were to continue this graph going down, there would be a negative 1 location right here somewhere. That would be right there. So notice there's a point on my graph when the time is negative 1, that's right there. That doesn't really show up, it doesn't seem to make sense, but that's what it's telling me. So you have to interpret this. So the calculator is only as good as the math behind it. So it is giving me that negative 1 answer, but that's not answering the question because we don't have those values that seem to make sense. So the question is, if I know this gap from negative 1 to here, which is 0, I know that this distance is 1, then I have symmetry because this sine graph is symmetric all the way along. So from this horizontal intercept right here on that x-axis, or really it's the time axis, I know this is 0, this is 1. That intersects my 10 feet below the water line. That means that this gap from 6 to this point, which I thought was 7, is also 1. And that means that this gap from here to here, this is actually 11, because that's going to be 1. So now I know that my estimate was close, but I know this gap is 1, because the calculator gave me -1 for a time when I'm 10 feet below the water level. So this gap is 1 right here. So this gap is 1 right here. And this gap is 1 right here. So now I know my actual answer is going to be this. So my solution is not from 7 to 11.5, but it's really from 7 to 11 in the morning, which really does this. So giving us 4 hours of time to build that sandcastle. So when should we build it? We have 4 hours in the morning. When does it start? 7 in the morning, and it goes until 11 in the morning. So the issue I want you to realize is that, yeah, we have this thing called inverse sine, which we used right here to calculate, to solve this equation for time. But keep in mind that inverse sine doesn't know we're dealing with a tide in a beach question. It's just doing some math that is defined as the inverse. So we'll talk next, not today, but not in this video, but in the near future, about inverse trig functions and why do they only give us certain values? Why does it not give us a value that's useful? Because in this example, the negative time has no meaning. We have to interpret that, and the graph is a nice way to interpret, to realize, all right, we have the symmetry, so that's 1 hour before, that's 1 hour after, 1 hour before, etc., etc. And we could continue that on the graph, even going here and saying if that's 18, then 1 hour before or after that would be 19. If that's 24, 1 hour before would be 23. So we have that same symmetric pattern happening. So we could find, if this is the same tide for days and days and days, when we'd have that 10 feet below the tide line, the average tide line, that would work out. Question on page 62 says something similar. It says, suppose you want to build a castle 15 feet above the average tide line. What's the maximum amount of time you'll have to make your castle? So once again, here is our function, f of t equals 20 times the sine of pi over 6t. We want to solve that equal to 15. And if we do this, we can look at the graph and talk about an estimate. So I'll put an estimate over here, but I really want to focus on this inverse trig idea. So we'll estimate the answer over here. Go back, look at the graph, go to 15. 15 feet is here, so 16, so 15 is right below 16, right about there. So we really want to think, all right, we're right in the middle of this square. So if we want to build our sandcastle, and keep in mind what we're doing is build a castle above 15 feet above the average tide line to give us more time. So the question is, when will we have more time as the water recedes to build that castle? So on this graph, the water is coming up. So this is higher tide, so this would be a wet beach, and then eventually the tide is going to go out. So it's going to be from here to here, and the question is, how much time is that? So we'll have more time. It's a bigger horizontal gap, so we'll have more time than this one was. The question is, what is that value? So if I had to guess, I'd probably say maybe from 5 till, I don't know, 13. That would be a good guess. So my estimate is going to be from 5 to 13, which is what, or that's 8 hours. And that's my guess. If I solve this equation, I divide both sides by 20. That's going to be 0.75 equals inverse sine of pi over 6t, or sine of pi over 6t. Take the inverse sine of 0.75, and then I'll make sure my calculator is in Radian mode. I'll type that in. So grab my calculator, grab your calculator, type in 0.75 make sure you're in Radian mode. So this calculator is ready. Radian mode, second for the inverse, I got 0.75. So if I type in inverse sine, I get approximately this number, 0.85. So I'll leave it like that. I'll leave that number in the calculator, but my time is going to be 0.85 times 6 over pi. So here's what the calculator will give me. So it's 0.85, multiply that times 6, and then divide that by pi, and I get 1.6 approximately. So a little dot above that equal sign means approximately. So that seems to be 1.6. So if I go back to my graph, does that seem reasonable? No, because I wanted the tide to go out, not the tide to come up. So this point seems to be 1.6. So that means from this 0 value, this gap right here is 1.6, but that's not what I want. I don't want the tide coming up, I want it going down. So if this is 1.6 past 0, then if this is 6, this point right here is going to be 1.6 before 6. And if I take 6 minus 1.6, that's going to be 4.4. So that's this value right there. And I have that 1.6 gap, so that means if this is at 15, then if I go back from 15, 1.6, this value, 15 minus 1.6, is going to be 13.4. Those are going to be my times. So it's really 4.4, which is like, I don't know, whatever 4.4 hours is past midnight, to 13.4. So my solution has to be interpreted again. So my answer is really going to be this. It's really from 4.4 to 13.4. Which is still, which is what, actually 9 hours. So I really have 9 hours of time, but it's around whatever 4.4 hours is past midnight to 13.4 hours. So a little time in the early afternoon. Last question, number 6. Suppose you decide you only need 2 hours to build and admire your castle. What is the lowest point on the beach where you can build your castle? So you only want 2 hours. So look at this graph, and you want to have a 2-hour gap. So the question is, how low can you go? So you either start here, or you could start here, and you want to have a 2-hour gap. So you want to go 1 hour before this point and 1 hour after this point. So if this point was right between 6 and 12, that would be at 9. So if that's 9, and that's right in the exact value, if you want 2 hours, you can go before 9 to 8 or after 9 to 10. So you could go from 8 to 10. So that would be an option. Or you could go, and that'd be in the morning. This would be 21 was the middle value down to here. So you could go 1 hour before would be 20, 1 hour after would be 22. So that would be late at night going towards the midnight of the next day. So for either from 8 to 10 or 20 to 22. So the question is asking you, suppose you decide you only need 2 hours, what is the lowest point on the beach where you could build your sandcastle? You only wanted 2 hours. The lowest point where you could build your castle would be low tide. So if you wanted 2 hours, you could go at 8, and that would give you 2 hours. Or you could go at, really, that's what, 8 o'clock. This is 8 o'clock in the morning. Go 12 hours later. 20 is really 8 hours past noon. So it's either 8 a.m. or 8 p.m. to give you 2 hours. So either one would be the amount of time you wanted. So it's either 8 a.m. or 8 p.m. for 2 hours of castle building. So that would work out. So just that idea that there's something interesting happening with inverse sine and also inverse cosine, etc., that it certainly has a definition that isn't giving us answers that we want. It's just doing some math that it's been programmed to as far as the calculator is concerned, and we'll talk during our next Google Hangout. So what's going on with this inverse thing, and why does math give us these answers and not the other answers that we want? And it's just giving us one answer on the calculator, so the calculator is being accurate. It just doesn't know the situation that we are at, so be careful about that. Alright, hope you enjoyed this video. Talk to you soon.